In this video, we will prove that divergence of f grad g, that is equal to f square of del operator g. This is your Laplacian operator del square. So del square g plus grad f dot grad g. Here g and f are scalar fields or scalar functions, and I have told you if a del operator operates on a scalar, that will give you gradient, and when the del operator operates on a vector, that will give you divergence. In the previous video, we have proved that divergence of phi a equal to phi divergence a plus grad phi dot a. This we have proved in the previous video. We have to remember this identity to prove various problems on divergence, gradient and Laplacian. Suppose here phi equal to f. We have taken f is a scalar field, so phi is equal to f and a is equal to grad g. G is also a scalar field, so a vector equal to grad g, and we know gradient of a scalar is a vector, so a equal to grad g. And using this identity, you can write that divergence of phi a vector, that means you have taken phi equal to f, so f into a vector is gradient of g, so gradient of g that is equal to phi divergence of a, phi equal to f, so f divergence of a means a equal to gradient of g plus grad phi dot a, that means here grad f, because f is phi equal to f, so grad f dot grad g, because a equal to gradient of g we have taken. So in the left hand side, divergence of f gradient g, that is equal to f of divergence then divergence of g. So that can be written as del dot divergence of gradient of g. This is your gradient of g, and divergence means del operator when operates on the vector, and gradient of g is a vector. Okay, so you can write this in terms of this divergence in terms of del operator, that f of del dot, this is a dot, gradient of g plus gradient of f dot gradient of g. So in the left hand side you have divergence of f gradient of g, that is equal to f, and del dot del, this is your square of del operator or Laplacian operator, or it is called Nabla squared. So f del square g plus gradient f dot gradient g, and this is your question to prove that divergence of f of gradient g, that is equal to f of del square g plus grad f dot grad g.